Hello students, how are you all? Welcome back to Akshar IIT Foundation classes. I am your chemistry faculty S. Mohan. Students, 7th class under volume 2 we are discussing about the chemical bonding, and till last class we completed 4 synopses, right? This is the 5th synopsis and the last synopsis of this class. So, don't think that with this the chemical bond topics chapter is totally done. No students, this chapter will be continued in the next year. Means what, when you go to the 8th class, from here it will be continued. Okay. So, this is a chemical bond chapter. Okay. So, it's a very big chapter, and here in the previous classes what we discussed, what is meant by the chemical bond. Next, we discussed about the ionic bond formation, and then we discussed about the properties. Then we discussed the Fazan's rule in the last class. Okay. Today, we are going to discuss about the covalent bond. Students, today we are going to discuss about what? Covalent bond. Covalent bond. Okay. So, in the last class, what we discussed in the last class, we discussed about the ionic bond. Ionic bond means what? The bond formed between two oppositely charged ions, right? Or the bond formed by the complete transfer of one or more electrons from one atom to another atom. But if you observe in the ionic bond, for example, some examples I'll write. Okay, in the ionic bond, we discussed about the formation of sodium chloride, right? And magnesium oxide and calcium chloride. So, like this we discussed, right? These are some of the ionic compounds. But I think you might have observed that in the sodium chloride, sodium is a metal and chlorine is a non-metal, right? And here you see in the magnesium oxide, again magnesium is a metal, oxygen is non-metal. And here calcium chloride, calcium is a metal and chlorine is a non-metal, right? So, here these all are metals and these all are non-metals. Means what? Generally, ionic bond is formed between metal and non-metal, right? So, we discussed about the ionic bond in which the bond is formed between metals and non-metals, because metals are electropositive in nature, which has the ability to donate the electrons, and non-metals are the electronegative in nature, which has the ability to gain the electrons, right? So, ionic bond is formed between metals and non-metals, right? Now, we are going to discuss about the covalent bond. Covalent bond, generally students, covalent bond is formed between the two non-metals. Between the two non-metals. Ionic bond is formed between metal and non-metal. But here the covalent bond is formed between non-metal and non-metal. Okay. How the non-metal and non-metal forms? So, here the bond is formed between the two non-metals by sharing of electrons. By sharing of electrons. The ionic bond, what we discussed, electron is transferring. One atom is giving the electrons, metal atoms are giving the electrons, non-metal atoms are taking the electrons. No, but here this will not happen, because here both are electronegative elements. Only non-metals are electronegative in nature generally. Okay. So, here the bond is formed by the sharing of electrons. By what? Sharing of electrons. So, the covalent bond simple definition is the bond formed, okay, by the sharing of electrons. Sharing of electrons. Okay, sharing of electrons means what? Electrons get shared. Okay, so how they share, I will explain you with examples. Okay, so now covalent bond is what? The bond formed by the sharing of electrons. Okay, so before going to the details about this one, then first we discuss about the types of covalent bonds, then I'll give the examples. Okay, when we see the types of covalent bonds, then we can see the homogeneous covalent bonds and the heterogeneous covalent bonds. Okay, so covalent bonds are of two types are there. One are called homogeneous, okay, covalent bond. Okay, and second one are what? Heterogeneous. Okay, covalent bond. Like this, two types are there. Okay, so what is the homogeneous and heterogeneous means what? If the covalent bond is formed between two similar atoms, then they are called homogeneous. Okay, and if the bond is formed, covalent bond is formed between two different atoms, then they are called okay, heterogeneous. Okay, means here the if the electrons are shared between two similar atoms, then that is called a homogeneous covalent bond. If the electrons are shared between two different atoms, then that is called a heterogeneous covalent bond. You can understand if I write the examples. So, example you see students here, I am writing example. Example here is hydrogen H2, oxygen O2, nitrogen N2, fluorine F2, chlorine Cl2, bromine Br2, like this. Okay, so here these all are homogeneous. Okay, now you understood now. So here the bond is forming. H2 means what? Hydrogen and a hydrogen, two similar. Okay, hydrogen and a hydrogen. For example, you see here, this is hydrogen, this hydrogen. Okay, so the bond is formed between two hydrogens. Okay, both are seen like black pens. Okay, so similar. Here O2 means what? The bond is formed between oxygen and oxygen. Nitrogen, the bond is formed between nitrogen. Okay, so if the bond is formed between two, okay, similar, okay, atoms, then that is called homogeneous. Heterogeneous means what? Heterogeneous means what? Two different. So this is blue, this is red. Sorry, black. Okay, so here, for example, if you see here examples like HCl, hydrogen chloride. Okay, and like you take water, H2O. Okay, then you take ammonia, NH3. Okay, so like this. So here you see, here one is hydrogen, one is chlorine, two different atoms. Here hydrogen and oxygen, two different atoms, and nitrogen and hydrogen, two different atoms. So if the bond is forming between two different two different atoms, different types of atoms, then that is called heterogeneous. Okay, heterogeneous molecules. Clear to you? Okay, so these are the homogeneous and heterogeneous. Okay, now let us discuss with some examples. Okay, students, here I'll explain some exampps here. Hydrogen, oxygen, nitrogen, fluorine. Okay, I'll explain you. Chlorine, bromine, you try. Here also hydrochloric acid is Cl, H2O, methane, CH4 also we can give an example. So this all we discuss. Okay, so that clearly you can understand the covalent bond. Okay, chalo. Now in this covalent bond, how the hydrogen molecule is formed. So see students here, hydrogen atomic number is 1, right? Electronic configuration is 1s1. Means what? How do we write the atomic structure of hydrogen? So structure of hydrogen we write like this is a nucleus. Okay, this is a one first orbit, and here one electron is there. This is one electron, right? Now this is one hydrogen. How the hydrogen molecule is formed? When one hydrogen combines with the other hydrogen, right? So here this is the nucleus and this is other hydrogen. Okay, this is also hydrogen, only one shell is there, one first orbit, and one electron is there. Now what happens? This both will approach. Okay, come close to each other. The bond is formed. When the bond is formed here, okay, this is the first hydrogen, this is the second hydrogen, like this. Now this electron which is there, this electron, okay, this hydrogen is providing this one electron and this hydrogen is providing one electron. Now see here, two electrons are shared by both the hydrogen atoms to form the hydrogen molecule. So now this is called a hydrogen molecule. Okay, so one hydrogen has one electron and other hydrogen has one electron. So as they have only one electron, they are unstable, they are not stable. To attain the stability, nearest inert gas configuration is helium. Helium atomic number is 2, it has 2 electrons. So if this also gains 2 electrons, means if it also can arrange 2 electrons in it, then it becomes stable. So now what happens? This hydrogen is combining with another hydrogen and forming the hydrogen molecule. So during the combination, what's happening? This hydrogen is providing one electron, this hydrogen is also providing one electron. The 2 electrons are shared by both the hydrogen atoms. So then the hydrogen molecule is formed. Clear? Okay. In another way also I'll explain you. Okay. In other way, how can I explain you? I'll rub this one. Okay. So see now, I'm rubbing this one. In other way, how can I explain you? So here you see students now, hydrogen. Okay. Atomic number is 1. So see here, hydrogen atomic number is 1. Okay. So here you see hydrogen. Yeah. So hydrogen atomic number is 1. Okay. So electronic configuration is 1. Means what? Hydrogen has only 1 electron. So how can you write hydrogen has 1 electron? So I can put one small cross here to represent the hydrogen. Now this hydrogen is combining with another hydrogen. That is also hydrogen. Its atomic number is also 1. So this also has 1 electron. Now what happens in the covalent bond? This hydrogen provides this 1 electron. Okay. This hydrogen provides this 1 electron. Now these 2 electrons will shared by both the hydrogens. Okay. So 2 electrons are shared. So now this generally covalent bond is represented by dash. Okay. This is a dash. So here this is covalent bond. So this is covalent bond as one pair of electron is shared. So like this the bond formed by the sharing of electron is called the covalent bond. Clear? Any doubt? Okay. So this is about the hydrogen. Now understood? No? Otherwise I'll explain one more example. Now one more example I'll take oxygen. Okay. I will take oxygen. So now see students here, for oxygen what we can do? So oxygen atomic number is 8. Oxygen atomic number is what? 8. Electronic configuration, how can you write 2, 6? Right? We write the electronic configuration as what? 2, 6. Okay, little bigger, right? Okay, so oxygen atomic number is 8. Electronic configuration 2, 6. Means what? Oxygen has 6 electrons in its outermost shell. Means what? Valence shell. Now, oxygen has 6 electrons. Is it stable? No, because we discussed that which have 8 electrons, octet rule, which have 8 electrons in their valence shell, that is stable. But here how many electrons are there? Only 6 electrons are there, so it is not stable. So it requires how many electrons? 2 electrons, right? Okay. Now this C. So generally now oxygen has 6 electrons. So how can I represent oxygen? See, oxygen here 1 electron, 2 electrons, 3 electrons, 4 electrons. Okay. I'll do one thing. So this 6 electrons now. So 1 electron, put the dot, 2 electrons, 3 electrons, 4 electrons, and 2 more electrons also there. So this 1 and 2. So total 6 electrons are there in the oxygen, right? Now this is combining with another oxygen. O2 means what? One oxygen is combining with other oxygen. So now see, this is other oxygen. Oxygen atomic number same. So it has a valence shell, 6 electrons are there. So 1, 2, 3, 4, 5, 6. 6 electrons are there, correct? Now 6 electrons are there. Now this oxygen requires 2 electrons to attain the stability because 6 are there. So octet rule, according to octet rule, it requires 8 electrons. So it requires 2 electrons. This oxygen requires 2 electrons. This oxygen also requires 2 electrons. So that's what these do. This oxygen share the 2 electrons. That oxygen also share 2 electrons. Means this is giving 2 electrons. That is giving 2 electrons. Totally become 4 electrons. That 4 electrons are shared by both the oxygen atoms. So now you see how the structure will be. So oxygen here 1, okay, 2, 3, 4. Now these 2 electrons, 5, 6. Other oxygen you see, this other oxygen, 1, 2, 3, 4, 5, 6. Okay. So this 6 electron, that's 6 electron. Now what happens? This oxygen is providing 2 electrons, this oxygen is providing 2 electrons. Now this total 4 electrons will be shared by both the oxygen atoms. Now if you see in this oxygen, how many are there? 2, 2, 4, 4, 6. Here 2, 2, 4, 4, 6. Now total 8, sorry. So 2 plus 2, 4, 4 plus 4, 8. Yeah, now this oxygen 2 plus 2, 4, 4 plus 4, 8. So both attain the stability. Now this oxygen has 8 electrons, that oxygen has 8 electrons. Okay. So now here how many pairs of electrons are shared here? 2 pairs. 1 pair, 2 pair. So what can I write? So 1 pair, 2 pair of oxygen are shared and these 2 electrons are left. Okay. So this is the structure of oxygen molecule. So this is the covalent bond. But as here two pairs of electrons are shared, two bonds are formed. How many bonds are formed? Two bonds. So this is called a double bond. What is called a double bond. And what it is called a single bond. Why? Because only one pair of electron is shared. So this is single bond. Clear? Right. Now let's go to the nitrogen. Okay, now let's go to the nitrogen. So how the nitrogen molecule forms? In nitrogen, atomic number is 7, electronic configuration 2, 5. So outermost shell, how many electrons has? Valence shell 5 electrons. Is it stable? No. Why? Because 5 electrons only are there. To attain the stability, how many electrons should be there? 8 electrons. But how many are there? 5. So it requires more 3 electrons. Correct? So now how the bond is formed? So observe carefully, nitrogen. So this is nitrogen. Atom valence shell 5 electrons are there. So this 5 electrons I am writing like this. Here 2 electrons, here 3 electrons. 1, 2, 3. So total 5 electrons are on the nitrogen. Right up. Now this is combining with the another nitrogen. Here also 5 electrons are there. So I'll put 1, 2, 3, 4, 5. Okay. So this nitrogen also has a 5 electrons. Now what happens? These both will combine. Nitrogen 1, 2, 3, 4, 5. Now this nitrogen 1, 2, 3, 4, 5. Now what's happening? This nitrogen, okay, is providing these 3 electrons for sharing. Okay, this nitrogen is also providing these 3 electrons for sharing. So this is providing 3 electrons, that is providing 3 electrons. Total how many electrons? 6 electrons. Now these 6 electrons will be shared by both the nitrogen atoms. Now you see in this nitrogen atom 2 here, 6 here, total 8. Octet rule attained. So this is stable. This nitrogen 2 electrons here, 6 electrons here, 2 plus 6, 8. That also attained the stable electronic configuration. Okay. Now how can we represent this one? So nitrogen, here 2 electrons are there, so 2 electrons, right? And here this is nitrogen. Okay, 2 electrons are there, 2 electrons. But here 6 electrons are shared, means for 3 pairs of electrons are shared. So for 3 pairs, we draw the 3 dashes. Okay, so 3 bonds means 3 bonds are formed, and this is called a triple bond. What is called a triple bond? So did you understand? So this is a formation of covalent bond. So the covalent bond, hydrogen here providing 1 electron. This is just providing 1 electron. These 2 electrons are shared by both the hydrogen atoms to form a single bond. In the oxygen, this is providing 2 electrons. This is also providing 2 electrons. So total 4 electrons. The 4 electrons are shared by both the atoms to form a double bond. So here nitrogen, here 2 plus 3. Here also 2 plus 3. Here nitrogen is providing 3 electrons. This nitrogen is also providing 3 electrons. So equally they are shared. Equal electrons are providing, equal electrons are sharing. So this type of bond is called a homogeneous covalent bond. Clear? This is what a homogeneous covalent bond. Any doubt? No. So this one. And one more important thing here. Students, here, for example, you see, here oxygen, okay, total number of electrons, how many are there? 6 are there. Okay, here also 6 are there. So, but these 2 pairs only participating in the bond formation. No, so these 2 electrons only participate in the bond formation. So, these pairs of electrons are called bond pairs. What they are called? Bond pairs, which are participating in the bond formation. Okay. Now, these two electrons are not participating in the bond formation. They are called lone pairs. What they are called? Lone pairs. Remember that the pair of electrons, which are participating in the bond formation, they are called bond pairs. Which are not participating in the bond formation, they are called lone pairs. Okay. Similarly, this is nitrogen. You see here, this total 5 electrons are there, but here 3 are participating in the bond formation and 2 are not participating. In this nitrogen also, these 3 are participating in the bond formation, these 2 are not participating. So this pair of electron is called lone pair, and this pairs of electrons are called bond pairs. So which participate in the bond formation, they are called bond pairs. Which participate in the, so do not participate in the bond formation, they belong to only one atom, they are called lone pair of electrons. Clear? So this is about the homogeneous. So in the homogeneous, what happens? The electrons are shared equally, because same number of electrons are shared, same atom, same type of atoms. So that's what they are equal, electrons are equally shared, so hence they are called homogeneous covalent bond and homogeneous covalent compounds. Clear? Chalo. 3 I explained you. Can you try these 3? Acha, 1 I'll explain you. Fluorine I'll explain you. Okay. So fluorine also I'll explain you. Otherwise chlorine. Here wish anything. Fluorine, chlorine, bromine. I'll explain you chlorine. So see here chlorine. Chlorine atomic number is 17. Electronic configuration 287. 287. So there are 7 electrons over there. Okay. In the valence shell. So how can you write chlorine? 1, 2, 3, 4, 5, 6, 7. Okay. Now you see here also this is combining with another chlorine. Chlorine 1, 2, 3, 4, 5, 6, 7. Right? So now here outermost shell has how many electrons? 7 electrons. So 7 electrons means how many it requires? Only 1 electron is required to attain the stability. Yes or no? Okay, atomic number is 17. Okay, so 18th element is the argon, that is the inert gas, right? So that's what it requires, only 1 electron. So these are called lone pairs. 1, 2, 3 are lone pairs. So only this 1 electron is left. Okay, so now what happens now? This chlorine 1, 2, 3, 4, 5, 6, 7. Now this chlorine 1, 2, 3, 4, 5, 6, 7. Now this chlorine is providing only 1 electron. This chlorine is also providing 1 electron. These 2 electrons are shared by both the chlorine atoms, right? So here only 1 pair of electron is shared. See now, only 1 pair of electron is shared. So 1 pair, and here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so this is the formation of a homogeneous covalent bond. Did you understand the covalent bond? Very simple, no? So the bond formed by the sharing of electrons is called a covalent bond. Covalent bond here 2 types, homogeneous and heterogeneous. Homo means what? The same. The bond, covalent bond is formed between 2 similar type of atoms, same type of atoms. Identical atoms are called homogeneous covalent bonds, and the bond formed between 2 different atoms, then they are called hetero. Hetero means what? Different. So these are different. Okay. Now we discussed here about what homogeneous covalent bonds. Now let's see the heterogeneous covalent bonds we discussed now. Clear? So now how the heterogeneous covalent bonds are formed? Now let's check that also. So right here 4 are there, or 4 I explained you, don't worry. Okay, so now hydrogen chloride. So hydrogen chloride means what? The bond forming between the hydrogen and the chlorine. So hydrogen atomic number is 1. See, already we discussed. So hydrogen has 1 electron. So I'm directly writing there. Okay, so hydrogen has 1 electron. So see here, hydrogen has 1 electron. Okay, plus it's combining with chlorine. So see, chlorine has outermost shell 7 electrons. See, directly I'm writing this one. Okay, so 1, 2, 3, 4, 5, 6. Here 7th electron. So I'm writing here chlorine 1, 2, 3, 4, 5, 6, 7. Right? Now this both will combine. So combining, what happens now? This hydrogen provides this 1 electron. This chlorine also provides 1 electron. Now these 2 electrons are shared by both the atoms. So now what happens? See, that hydrogen 2 electrons are there. So this is stable according to duplet configuration. And here chlorine has 8 electrons, 6 here plus 2, 8 electrons. That's octet configuration. This is also stable. So now hydrogen 1 pair of electrons is shared. So chlorine 1, 2, 3, 4, 5, 6. Okay, so like this, hydrogen chloride molecule is formed. So hydrogen is providing 1 electron, chlorine is providing 1 electron, the 2 electrons are shared. The covalent bond is forming between hydrogen and chlorine. Hydrogen, chlorine, 2 different elements or different atoms. So hence this bond is called the heterogeneous covalent bond. What is called? Heterogeneous covalent bond. Right? Now let's go to the second one. What is the second one? Water. Okay. So how this water? So here in the water molecule, how many hydrogens are there? 2 hydrogens are there. How many oxygen is there? Only 1 oxygen is there. Oxygen is 1 and hydrogens are 2. Right? So oxygen will be in the middle, and here with one hydrogen, here with one hydrogen. So now it will dance. Okay, so here one hydrogen, here one hydrogen, oxygen in the middle. Now it forms the water molecule. Clear to you? So here it is forming the bond with this hydrogen. This oxygen is forming here also one bond with this hydrogen. Two hydrogens it's forming. Okay. So now let's see now. So see now oxygen. Oxygen already we discussed. So 2,8 its electronic configuration. Oxygen has 6 electrons around it. Okay. Oxygen has how many electrons in the valence shell? 6 electrons. See students now. Oxygen has 6 electrons. So see here 1, 2, 3, 4, 5, 6. Right? 6 electrons. Okay. Actually, the structure is little different. But okay. Now here I am writing because here. Okay. So like this, 6 electrons are there. Correct. Now this oxygen is combined with how many hydrogens? 2 hydrogens. Hydrogen atomic number is 1. Hydrogen has only 1 electron. Hydrogen has only 1 electron. So now hydrogen has 1 electron. Here this side also one hydrogen has 1 electron. Correct. So now the bond is formed. This hydrogen is providing 1 electron. Oxygen is providing 1 electron. So here this can share. Here hydrogen is providing 1 electron. Oxygen is providing 1 electron. These 2 electrons will be shared. Now this oxygen is combining with both the hydrogens. No? So now this will share all the electrons. Now you see every hydrogen has 2 electrons of duplet rule stable, and oxygen has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons already. This is a stable now, octet configuration. Okay. So here how can we represent this one? Oxygen in the middle and 2 hydrogens are there. But actually I said that they are exactly side, but you learn the structure will be little different. So the hydrogen will come this side, this hydrogen will come this side, and here 2 pairs of electrons are there. This is the structure of water molecule. So you now see here the bond is forming between oxygen and 2 hydrogens. Different oxygen and 2 hydrogens. So this is different. Hence this is called heterogeneous. Understood? But here also the bond is formed by the sharing of electrons. The hydrogen is providing 1, oxygen is providing 1. So these 2 electrons are shared. This is 1 electron, this 1 electrons. Oxygen is shared. Okay. So this is the formation of water molecule. Clear? Chalo. Now let's go to the third one. Third one is what? NH3. Do you know what's NH3? Molecule is called? Good. That is ammonia. Okay. Ammonia. So ammonia how can form? See nitrogen. It's combining with how many hydrogens? 3 hydrogens. How many hydrogens? 3 hydrogens. Means 1, 2, 3. Okay. So total 3 hydrogens are there. 1, 2, 3. So 3 hydrogens. Okay. So nitrogen is combined with 3 hydrogens. How it will combine with 3 hydrogens? Now let us see now. So see here nitrogen atomic number is 7, 2, 5. 2, 5. Means nitrogen has 5 electrons in its valence shell. Nitrogen has 5 electrons in its valence shell. Okay. 5 electrons. See here 5 electrons. So see here now nitrogen. Okay. So one lone pair, 2 electrons, and I'll put 1, 2, 3. So total 5 electrons here. Valence shell has 5 electrons. Okay. So 5 electrons. Nitrogen 2 electrons, 3, 4, 5 electrons. Correct? Now this nitrogen is combining with how many hydrogens? 3 hydrogens it is combining. Hydrogen has 1 electron. So see here now. Hydrogen has 1 electron. Hydrogen has 1 electron. Hydrogen has 1 electron. Right? Now this hydrogen is providing 1 electron. This nitrogen is providing 1 electron. These 2 electrons are shared like this. This nitrogen is providing 1 electron. Hydrogen is providing 1 electron. Shared like this. This nitrogen is providing 1 electron. This hydrogen is providing 1 electron. So shared like this. Now here nitrogen is combining with all hydrogens. So it will share all the electrons. Now you count now the electrons in every atom. Hydrogen, C and hydrogen atom 2 electrons. Stable. Inert gas configuration of helium. This hydrogen 2 electrons. Stable. This hydrogen has 2 electrons. Stable. This nitrogen has here 1, 2, 3, 4, 5, 6, 7, 8. 8 octet rule has 8 electrons. This also stable. Correct? So now how can you draw the structure? The structure you can draw nitrogen which has say one lone pair of electrons. So put one lone pair of electrons, and it's combining with 3 hydrogens, single bond. So like this, you write one nitrogen, second nitrogen, third nitrogen. Okay, sorry, hydrogen. Sorry. This is hydrogen. Okay, so like this now, ammonia is formed. How this ammonia is formed? By sharing of electron. So the sharing of electron is formed, that's called what? Covalent bond. And the covalent bond is formed between different atoms, nitrogen, hydrogen. So hence it's called heterogeneous. Clear? I hope you can do the methane. Can you? Yes or no? It's a very simple. Okay. So carbon atomic number is what? 6. Right? Carbon atomic number is what? 6. So we can write the electronic configuration as what? 2, 4. Yes. So carbon has 4 electrons in its outermost shell. Put 4 sides. 4 electrons. So here I am writing here carbon. Can you see here? Okay. Can you see here carbon? Carbon has 4 electrons, 1, 2, 3, 4. And it's combining with 4 hydrogens. So hydrogen has 1 electron, hydrogen has 1 electron, hydrogen has 1 electron, hydrogen has 1 electron. So like this they share, like this they share, like this they share, like this they share, and here carbon will share like this. So every hydrogen has see 1 pair, 1 pair, 1 pair, 1 pair. So now we can write 1, 2, 3, 4. Like this 4 bonds are formed. Okay, so this is, you try this structure, students. So this is about the covalent bond. Clear covalent bond? Any doubt? No? Sure. So simple, covalent bond is nothing but just bond formed by the sharing of electrons. If the bond is formed by the sharing of electrons between 2 similar atoms, then that's called homogeneous. If the 2 different atoms, that's called heterogeneous. Okay, that's all. And generally covalent bond formed between the 2 non-metal acids. See, can you find anywhere the non-metals? Hydrogen is non-metal, oxygen, nitrogen, fluorine, all are non-metals. Here chlorine, oxygen, nitrogen, all are non-metals. So the bond is formed between 2 non-metals. Right? Now see students here, covalent bond is also classified into 2 types. Okay, like a polar covalent bond, non-polar covalent bond. What is that? Polar covalent bond, non-polar covalent bond. Polar means what? Which has little charge. Okay, which has little charge is called polar. And non-polar means what? No charge. Okay, completely neutral, completely. Okay, so that's called non-polar. Okay, so here homogeneous all are non-polar, heterogeneous or polar. Okay, how can you say these are non-polar, this is polar? Because these students here, these are okay, both 2 are hydrogens, so both are sharing. So both are equally sharing. Yes or no? The electrons are equally shared by both the atoms. No. So that's what it is non-polar. But here what happens? Here if you take hydrogen and chlorine is more electronegative than the hydrogen. More electronegative than the hydrogen. Okay. So then what happens? This electronegativity is what? The ability to attract the electrons. So chlorine has more ability to attract the electrons. So here the bond is formed between hydrogen and chloride. Hydrogen is providing 1 electron, chlorine is providing 1 electron. So both are sharing. But the thing is that these two electrons, this pair of electrons are not shared equally by both hydrogen and chlorine. Why? Chlorine is more electronegative, so it pulls that electrons towards itself. That electron pulled towards itself means what? Chlorine is pulling the electrons very close to, but hydrogen, this electron is far. So due to that, what happens? This chlorine acquires electrons pulling close to this one. So electron is slightly moving towards the chlorine. Okay, so moving towards the chlorine, so electron is negative charge. So due to that, what happens? This chlorine attains partial negative charge. What it attains? Partial negative charge. As electron is going little away from the hydrogen, so electron is negative charge. As negative charge is going away, so this hydrogen possesses a little positive charge. That's called partial positive charge. Now, if you take the hydrogen chloride molecule at one end means near the chlorine end, there will be little more negative charge, partial positive charge, negative charge is there, and towards the hydrogen end, there is a partial, means what, little positive charge is there. So on the two ends, two opposite charges are there. Okay, so hence this is called a polar covalent bond. What is called a polar covalent bond? And here they are equally sharing the electrons, so they are called non-polar covalent bonds. So these are non-polar and these are polar. So polar covalent bond is formed between the two similar type of molecules, and if the covalent bond is formed between two different types of molecules, those compounds are called polar covalent compounds. Okay, these are called non-polar covalent compounds. So once you see, students, in the page number 43, there is a non-polar covalent bond. If the covalent bond is formed between two identical atoms, here, if the covalent bond is formed between two identical atoms, then the electron pairs are shared equally between the two atoms, So the meaning is what? The shared electrons are equally attracted by both the nucleus of both the atoms. As a result, the molecule is neutral. Neutral means what? No charge. So hence these are called non-polar. Example: hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, etc. These are clear. Now come to the polar. See, if a covalent bond is formed between two dissimilar atoms, dissimilar means what? Not similar atoms, then the electron pairs are shared unequally between two atoms. So see here, hydrogen and chlorine. Here also hydrogen is providing one electron, chlorine is providing one electron. Two electrons are shared, but they are not equally shared. Okay, so here chlorine being more electronegative, this pulls that pair of electrons towards itself. So due to that, what happens? The chlorine attains a partial negative charge, hydrogen attains a partial positive charge. Okay, so that means the shared electron is not equally attracted by both the nucleus. So the atom which has higher value of electronegativity attracts the shared pair much strongly than the other atom. So in this two, chlorine is more electronegative, so it attracts the pair of electrons morely. So then the shared pair of electrons nearer to the more electronegative. As a result, the more electronegative atom acquires partial negative charge, and the less electronegative element acquires partial positive charge. So the molecule which have two oppositely charged poles, two oppositely positive and negative oppositely charged poles, is said to be a polar covalent bond. What are they? Polar covalent bond. Did you understand? So these are the non-polar, these are the polar. These are the difference between the polar and non-polar. Okay. Next, now let us see what are the properties of covalent compounds. Generally, covalent compounds may be solids, liquids, or gases. Okay. So covalent compounds are what? Generally solids, liquids, or gases. So here you see, in the ionic bond we discussed, ionic compounds are mostly solids. All are solids almost. Okay, solids. But here they may solids, they may liquids, they may gases. So for example, you see these are the gases, and you see water is a liquid. So they may be solids, liquids, or gases. And they have low melting and boiling points. Where we discussed in the ionic bond, they have strong, means they have high melting and boiling point, because the strong force of electrostatic force of attraction, present between the two atoms. So that's what they are very strong. So require more energy to break them. So that's what the melting and boiling points are very high there. But in the covalent compound, the melting and boiling points are low. And covalent compounds are not hard, nor brittle. And covalent compounds are soluble in non-polar solvents like kerosene. Okay, so for example, take the naphthalene powder. There's a covalent compound. It is soluble in kerosene. But ionic compound, if you take the salt if you dissolve in the kerosene, any oil, it will not dissolve. Okay, but here covalent compounds can dissolve in the non-polar solvents like kerosene, ether, benzene, etc. Okay, so these are the properties of the covalent compounds. So what are the properties? Covalent compounds exist in solids, liquids, and gases, all the states. and covalent compounds have low melting and boiling points. They are not hard, they are not brittle, and they dissolve in a non-polar solvents. Okay. Now, let us see some questions, concept based questions. So, you see in the page number, open the page number 45. The page number 45, you have some questions. So, now let us answer these questions. Okay. Now, first question. The bond formed by the equal sharing of electrons between two atoms or more atoms is called the bond formed by the sharing of. So, what is that? Covalent bond. Covalent with the bond formed by the sharing of electrons. That's what covalent bond. So, the option is the second option. Okay. Second question. The covalent bond formed between two non-metals when electronegativity difference is less than 1.7. Students, in this I already explained you in the ionic bond. So, if the electronegativity difference, if it is greater than 1.7 between two atoms, then that forms a ionic bond. If it is less than 1.7, that forms a covalent bond. So, here the option is a third option, that is 1.7. Okay. Third question. The electron pairs are involved in the bonding. See, the electron pairs involved in the bonding. What I said, they are called bond pairs. What they are called? Bond pairs. I said, so these are called bond pairs. So, option is what? Fourth option. Okay. Next, the electron pairs are not involved in the bonding. Not involved in the bonding. So, this one. So, they are called what? Lone pairs. They are not participating. So, they are called what? Lone pairs. Right. So, these are lone pairs. So, the option is what? Fourth one, 1. Okay. Next, the force of attraction between the inert gases molecules are. So, inert gas molecules are van der Waals forces. Van der Waals forces is what? Weak forces, students. Weak forces or van der Waals forces. The covalent bond is formed between hydrogen and oxygen. Hydrogen and oxygen. See here. Hydrogen and oxygen. Okay. Is homogeneous, heterogeneous? Heterogeneous. So, here this are the heterogeneous. So, the answer is heterogeneous. So, option is 2. Next, which of the following are homogeneous covalent compounds? Hydrogen, yes, homogeneous. Chlorine, yes, homogeneous. Oxygen, yes, homogeneous. So, all are homogeneous. So, all of these is the option. 7th is fourth option. 8th one, which of the following are heterogeneous compounds? HCl, yes, heterogeneous. Water, H2O, yes, heterogeneous. Ammonia, NH3, yes, heterogeneous. All of this. So, 8th one is also fourth option only. 9th one, graphite is dash conductor of electricity. It's a good conductor. Right? Students, here this is a carbon allotropic form. Okay, diamond, graphite, C60, which are called allotropic forms of carbon. Even though it is carbon is a non-metal, but the graphite it's a good conductor. Okay, so the option is 9th one is first option. The melting point of diamond. Student, the melting point of diamond is, the diamond is one of the hardest material that is available in the nature. So, this is approximately 4,000. Okay, so what you can write? Second option you can write 3,900. Okay, Celsius. Covalent compounds are soluble in, just now I told you that covalent compounds are soluble in non-polar solvents, okay, like kerosene, benzene, ether, etc. Okay, the option is non-polar, that is 11th one is 2. Okay, next come to the 12th one. So, 12th one, covalent compound possesses, just now I told you the low melting and boiling points. So, low melting point, low boiling point, both 1 and 2, is the right option. Next, reactions of covalent bonds are, generally the covalent bonds, reactions are covalent bonds are slow reactions. Okay, so that's all, students. So, with this, we stop today. Remaining questions, what are they that you practice? Okay, so first read, try to understand this one. So, see this everything very simple, everything is on the board only. So, first you try to understand this one and read the material and then practice the structures. Okay, and then try to answer these questions. Okay, so you can do it. With this, we completed our first chapter from the volume 2. With this, we completed the first chapter from the volume 2. Okay, so very important chapter. So actually, chemical bond chapter is very big chapter. So the chapter is not means in the 7th class we have stopped here. But this chapter is very big chapter. Again, it has a coordinate bond like dative bond, metallic bond, so many things are there that we learn in the higher classes. Means in the 8th class, we'll study from here. So to understand that, till here you have to be very perfect. Okay. So take care. With this, I stop. Bye.